Okay. Can you introduce yourself?
My name is Thomas Lamott. I am an aerospace project engineer at Stratasys Direct Manufacturing.
Thank you. How did you get involved in 3D printing?
I went to Iowa State University and got a bachelor's of science in mechanical engineering, and I worked at a chemical company down there, and I applied to a job at Stratasys' paid parts division, which used to be called Red Eye. It's now, Stratasys Direct Manufacturing, and I applied and I got the job. So I've been working here for 6-7 months.
Cool. Okay, so what kind of 3D printing does your company specialize in?
So we have two processes that we produce machines for. One is called Fused Deposition Modeling, or FDM. That's what the MakerBots and those sort of machines use. And then there's also PolyJet, which works more like an inkjet printer, and it deposits small droplets of photocure resin that when it contacts ultraviolet light, it hardens. Does that answer your question?
Yeah. Also, is there a type you personally prefer in 3D printing?
I like the FDM printers, but that's totally subjective. One isn't necessarily better than the other. It totally depends on the application.
Oh, okay. Well, thank you. 3D printing is still new. So, in your opinion, what was the biggest accomplishment that made 3D printing possible?
I believe it was the personal computer coming out of the Apple II in the late 70s, early 80s. Really paved the way for 3D printing. Any of the existing technologies couldn't be used without a personal computer or a CAD software, computer-aided drafting. Because to build 3D parts, you need a 3D model.
Okay, well, thank you. So, what is the greatest challenge in 3D printing market today?
There's a lot of them, but I would say that it's a growing market, so everyone's competing for market shares. So there's a lot of smaller companies that are entering the market. But yeah, that works. Excuse me.
Yeah. What is the biggest benefit to 3D printing?
So there's a lot of them. I'd say maybe the biggest one is if you only wanted 1 or 2 or 3 parts of a given geometry, the price per part would be more expensive than if you were to injection mold it, but your total cost is cheaper. So if you wanted 5 parts with FDM, let's say it costs $100 a piece. If you wanted to injection mold those parts, it could be $3 a piece, but you're going to have $20,000 invested into a injection molding tool, the actual mold for it. So you would have to divide the cost of the mold into those 3 parts, and then all of a sudden your $3 part is, $1,003.
Oh, well, that's cool. So what does the future of 3D printing look like?
That's a really good question. That's kind of like asking what cell phones are going to look like in 10 years. I have no idea. But the chances are they'll have a lot more cool materials, and the printing speed will be dramatically increased.
Okay, that's good. What is the printing speed now?
Really hard to say. I work in the paid parts division, like I said, so I see a lot of different geometries, and people ask me that and other questions, and the answer, unfortunately, is it's geometry dependent, meaning that I could only tell you if I had the part. So it's basically, in short, it's a very difficult question to answer.
Okay, thank you. So is there anything else you think that we should know about 3D printing?
It's some people would believe that it's a disruptive technology, meaning that it will disrupt the sort of the current sort of development chain. So nowadays, just about everything is made by a subtractive process or a molding process. So 3D printing can build parts without either of those things. So it can make a lot more custom parts. So if you had a lot of money and you were in professional sports, you know, I see in the future you'd have shoes made just for you, so they'd scan your feet, or in some of those sort of applications where it doesn't really matter if the cost of the part is really high. In professional sports, there's a ton of money for that sort of thing. In like aerospace applications, that's where I specialize in. There's like ductwork and that sort of stuff. It's very difficult to produce in non-additive manufacturing ways. And when you design parts, a lot of it's for subtractive manufacturing, so we're able to help engineers design parts different ways that lower parts count, which doesn't seem like much, but it can lower costs significantly because the people that actually put the parts together, if there's less parts, it's a lot easier for them, and it can happen much quicker. So you're able to make airplanes quicker and that sort of thing.
Do you think everyone will have a 3D printer?
I'd like to say I hope so, but I honestly don't know. There's analysts in the 3D printing industry like to make the connection between the sort of personal computer boom of the late 80s, early 90s, that a lot of people didn't think that they were going to be used outside of university research, and then fast forward 20 years and everybody has one. So I'd really like to say that everyone will, but I couldn't tell you one way or the other.
That's really cool, though.
Yeah, if the materials get better and the speeds get faster, I could definitely see it. Because you could make, car bumpers and all those sorts of things. So instead of going to the body shop, you could just make a new bumper and put it on yourself. So the ideas are pretty much endless.
So thank you for helping us with our interview. We appreciate you investing your time in this project.